The day 15 of Advent of Cyber. Let's dive into the storyline and see what's happening in the city of Weville and what is our job role of today. Diving into the story, we see the best festive company's drone scheduler web UI is getting strange, long HTTP request containing base 64 chunks. Splunk raises an alert. Apache spawned an unusual process. On some endpoints, these requests cause the web server to execute shellcodes, which is obfuscated and hidden within the base 64 payloads. For this room, your job as a blue teamer is to trigger the incident, identify the compromised host, extract and decode payloads, and determine the scope. Well, that's interesting. You will use Splunk to pivot between web logs and host level telemetry. Follow the investigation steps below. Each corresponds to Splunk query and investigation goal. Well, that's the storyline and sounds interesting. We are doing something related to some analysis. Fine. So today's learning objective is to detect and analyze malicious web activity through Apache, access, and error logs. Investigate OS level attacker action using sysmon data. Then identify and decode suspicious or obfuscated attack payloads. Reconstruct the full attack chain using Splunk for blue team investigation. Well, that's good. So connecting to the machine, we have to start a VM and the attack box. So let's click on both of them, and that should start at spawning the machine. Well, that's good. Now let's get into web attack forensic. After you have started the attack box and target machine in the previous task, allow the system around 3 minutes to fully boot. Then use the Firefox on the attack box to access Splunk dashboard at the IP address using the credentials below. So we need some time for the machine to boot up and show the IP address. So till then we'll continue reading and then maybe come back once again and then start doing the hands-on stuff. The Splunk login page should look similar to the screenshot given below. Yes, that's how it is going to look. After logging in successfully, you will be taken to the search page as shown in the screenshot below. Okay, well, the machine has booted up. So let me press on enter to close that terminal. Open up Firefox here. Then copy this URL. I guess the Firefox is loading. Well, let's replace with the clipboard. Paste this clipboard in and paste the URL that we will be accessing. Also close this. Yes, we get the dashboard there. Now the username is blue, so we can type that in the username field. Then the password is pass1234. So pass1234. Then we will log in into it. Click on sign in. Okay, that's loading. After logging in successfully, you will be taken to the search page as shown in the screenshot below. So this is going to be the dashboard of Splunk. Make sure to adjust the Splunk time range to include the time of events. Example, last 7 days, all time. In the default range is too narrow. You may see no results found. Okay, so this is the search bar here. Now what I can do is I'll open this in full screen so that we can have a better view of the attack box. And probably let me also close here, exit split screen. This should be sufficient for us. Okay, this also looks good. So let me reduce the size of my window. I can accommodate the entire screen here. Okay, here it says the time range that we can select. Now we have option of last 7 days and click on search. Do we get anything there? No. We can click on all time and no. Basically we need to select some modules, but that's where we can select what the kind of time range that we want to actually analyze and see the information from. Make sure to adjust the Splunk time range. That's done. A blue teamer would explore various attack angles through Splunk. In this task, we will follow Elf Log Mech Blue, who uses his Splunk magic to unravel the attack path. Detect suspicious web commands. In the first step, let's search for HTTP requests that might show malicious activity. The query below shows web accessing logs for any HTTP request that includes the sign of command execution attempts, such as cmd.exe, PowerShell, or invoke expression. This query helps identify possible command injection attacks, where the evil attacker tries to execute system commands through a vulnerable CGI scripts hello.bat. So also they have given the entire query that we can use for searching. Now for the search, let's come here, and these are all the commands which was earlier used. So the endpoint of the data might have been selected, or like where exactly we want to search. Those points might have been already filled. So what we'll do is let's just copy this part of the query and paste it into the clipboard here. Let's replace that with this. Then paste this inside. Press enter. That started to give us some requests. So now what this command does is it's going to look for the index which says Windows Apache access. So it's nothing but accessing the Apache server, though that is going to be our index that we are trying to filter out. Then command exe or PowerShell or PowerShell.exe or invoke expression. So does that contain any of those keywords which might be invoking any system related commands like the PowerShell or the command line utility or any services which is going to be giving you an access command line interface through a web application. So this is what the filters that we want to see. And in the table, we want to see the time when this was done, also the host, which who did it, or to which it was done to. Then the client IP address, what was the client IP address who was trying to access it. Then the URI path, what was the URL that was being accessed with. Then it says also the URI query. Last comes the status. So this was the query which was run from these URL paths. Okay, with that basic understanding, after this step, we are primarily interested in the base 64 encoded strings, which may reveal various types of activities. Once you spot encoded PowerShell commands, decode them using base64decode.org or your favorite base64 decoder to understand what the attacker was trying to do. Based on the results we received, let's copy the encoded PowerShell string and paste it into this upper field, then click on the decode as shown below in the screenshot. Okay, what we'll do is instead of using that, we also have another powerful tool called as Cyber Chef, which is my personal favorite tool when it comes to encoding, decoding, or hashing any of these contents. So also let's copy the command here. Now if you see this, it says command line or the CMD as a parameter. It's trying to invoke PowerShell here. Then this part of the query which says it's going to be running something is encoded in base 64. So let's copy this entire text here. If it's possible, I'll take it from the clipboard here. Yes, I copied the base 64. As you can also see, they have just pasted that into the input box. So we have something similar to that itself into input box here. You can enter the base 64 character that you want to decode. That's going to come here. Then the search operator will search for from base 64. That's going to load the parameter that we want to use. And we see something like this is now mine. Muha. It's kind of encoded with some random gibberish also in between. I guess that's all URL encoding parameters. I'm not sure. So we have some garbage also in between, but mainly we can see the ASCII characters to say this is now mine. Muha. Something which Malhare would be doing. Now, looking for server-side errors or command execution in Apache error logs. In this stage, we will focus on inspecting web server error logs, and this would help us uncover any malicious activity. We will use the following query. It says index, again, the Windows Apache error. So if there is any error generated from it, basically anything, any services related to Apache is going to be shown there. Then command, what did I do? Oh, let's close that. It's going to say command prompt.exe or PowerShell or internal server error. So we are now looking after some errors which they would have got when we are trying to run the script that they want to see. So let's also replace this here. Then replace the entire search parameter with this to see what are the logs that we get when there is some error which is generated. which has PowerShell or internal server error in them. Um we see some data here. We can even make this down, and we can see it says Windows Apache error, and what was the Apache error type. All those can be viewed from here. Now let's continue reading and see what exactly we need to be doing. This query inspects Apache error logs for the signs of execution attempts or internal failures caused by the malicious request. As you can tell, we're searching for error messages with particular terms such as command cmd.exe and PowerShell. Please make sure you select View Raw from the drop down menu above the event display field. So that's going to be where exactly? So event is here. Oh, view. Instead of list, it's going to be raw. Okay, now I get it. Fine. That's done. If a request like CGI bin hello bat command prompt PowerShell triggers a 500 internal server error, this often means that the attacker's input was processed by the server but failed during execution, a key sign of exploitation attempt. Checking these results help confirm whether the attack reached the backend or remained blocked at the web layer. Tracing suspicious process creation from Apache. Let's explore Sysmon from other malicious executable files that the web server might have spawned. We will do that using the following Splunk query. And they have given another query which says index is Windows Sysmon, then parent image is http.d. So anything which would be running the HTTP service image is going to be shown to us. So let's replace this content there, then replace this query with the new query that we want to search. Now we see 14 logs, which talks about what was actually happening in there. Now we can see some of the information. It says it's Microsoft Windows Sysmon, which is nothing but talking about the systems events that's happening. The thread ID, Microsoft. I'm exactly not sure what are we supposed to be looking at here. That's the reason I'm just blindly brushing through the page to see what contents might be potentially stored there. The summary of that is also shown here, something which is found from it. Okay, let's continue reading because I'm not clear with what we'll be looking here. The query focuses on process relationships from sysmon logs, specifically when the parent process is Apache, the httpd.exe file. Select View Table on the drop-down menu above the event display field. So here, let's click on the table option to see it in our table view. So we see the timeline of when the event happened, the event code which is given there. Then we have the computer which is trying to access it. Then the image, like the command prompt is being invoked here. Command line is also shown there. Then the user who was accessing it. It's the Apache SVC is the user that was accessing the file or was having a control over it. Okay, with that, now typically the Apache should only spawn worker threads, not system processes like command prompt or the PowerShell. If the results show child process such as parent images, see Apache 24 bin httpd.exe and images see Windows system that do cmd.exe. Yes, did it show that? So the image was all command prompt based thing, and we can also see some of them to say Apache 24 bin http.d. It indicates a successful command injection where the Apache executed a system command. So this means that the user was successfully able to compromise the server and then execute some system level commands in it. The finding above is one of the strongest indicators that the web attack penetrated the operating system, which means they have got control of the operating system from the web application itself. Confirm attacker enumeration activity. In this step, we will aim to discover what specific programs we found from previous queries to do. Let's use the following query. Index Windows Sysmon cmd.exe who am I. So we are checking to see if they have run any commands like who am I to see what users have they logged in as, or these are all the commands which we run as an initial access. Once we get the initial access to see what is the level of privileges that we have, what is the username, to do some understanding of the environment, we run such commands like who am I. So we are trying to see if that command was executed, and we also see that it was executed from the whoami.exe, which is present in the bin folder of the Apache here. So yeah, that exe was executed there. The query looks for the command execution logs whereas cmd.exe rather than the command whoami. The query looks for the command execution logs where the cmd.exe ran the command whoami. The attackers often use whoami command to immediately after gaining code execution to determine which user account their malicious process is running as. Finding these events confirm attackers' post-exploitation reconnaissance, showing that the injected command was executed on the host. Yes, we were able to confirm with that. Now, identify base 64 encoded PowerShell payloads. In the final step, we will work to find all successfully encoded commands. To search for encoding strings, we can use the following Splunk query. Here we are running again the Windows sysmon logs to see for the image anything related to PowerShell, and the command line is encoded or encoded command, and it's with base 64. So they are encoding their phrases or the payloads in the base 64 format. So we are trying to see if that is happening or do we see any related activities happening in the system. And it says no results found. There is no base 64 command. Should we replace the base 64 parameter there? No. Yeah. It says no results found. Okay. This query detects PowerShell command containing encode commands or base 64 text, a common technique attackers use to hide their real commands. If your defense are correctly configured, the query should return no results, meaning the encoded payloads such as Muha messages never ran. If the results appear, you can decode base 64 commands to inspect the attacker's true intent. Well, in our case, then we have not got any results, which means that there was no successful compromise of the thing. What is the reconnaissance executable file name? It says whoami.exe, right? Well, it worked this time. This is, I don't know what was wrong with it. What executable did the attacker attempt to run through the command injection? So, executable, it's going to be PowerShell.exe. Yes, that's right. With that, we have finished today's challenge of doing some web based forensic or analysis. Let's click on continue. All these things, that's fine. Continue. Okay. Let me. Yes, that's done. Let's click on continue. Close. And yeah, so we finished the web forensic, and yeah, that was it for today's video. So yeah, till then, let's meet you all in the day 16 of Advent of Cyber. Till then, stay happy, stay smiling. Thank you for watching. Bye bye. See you in the next video. Bye bye.